Hello everyone, how are you all? I hope you all are well. So welcome back to our new video. Now today we are going to discuss a very important topic from the chapter solution. Already we have discussed some of the topics from the chapter solution, like we have already discussed about their concentration, how to measure the concentration and how to solve the numericals related to the concentration of the solutions. So if you haven't seen those videos, just click on the I button and just see those videos. Now we are going to discuss one more topic from the same chapter, that is solubility. Now solubility, when we are saying, it means we are talking about to prepare solution. So again we are talking about here two components, that is solute and solvent. So let's see what is solubility all about. Solubility means basically the amount of solute. When we are saying amount of solute, why? Because solute is an important component which is required to prepare solution. So amount of solute to be dissolved, okay, because solute is a component which is going to be dissolved in unit volume of another component which is solvent. Okay, see, the amount of the solute to be dissolved in unit volume of solvent, that is the maximum amount of the solute we are talking about, is known as the solubility of that solution. Okay, so solubility means the amount of the solute to be dissolved in a given amount of the solvent, that is unit volume of the solvent. So basically we are talking about the addition of the solute in a given solvent and then we prepare a solution. So whatever the maximum amount, this is very important term here, that is maximum amount of the solute which is dissolved in a given amount of solvent. But one more thing, at a given temperature, means we are keeping the temperature constant at that point. We are keeping the temperature constant, then only whatever the maximum amount of the solute which is dissolved in a given amount of solvent, that is known as its solubility. Okay, because if you vary the temperature, then the amount of the solute which is going to be dissolved in a given amount of the solvent may also vary. So if you want to calculate the actual value, then you have to keep the temperature value constant. Okay, so that is solubility. Now solubility can be of different type, like the solid substance can be dissolved in the liquid solvent. Okay, when I am saying solid substance, means I am talking about the solid solute. If solid solute can be dissolved in a given amount of the liquid solvent, that may be also the considered as a solubility. Or maybe the liquid solute, okay, the solute is liquid and the solvent can also be liquid. Okay, so that can be also used to prepare the solution and the solubility can be measured. And the last one is, like, this is 1, this is 2, and the third one is like gaseous solute, okay, to be dissolved in liquid solvent. These are the major one which we are going to discuss. So basically in this chapter we are going to discuss about the solid in liquid, liquid in liquid and gas in liquid. So that is how we can prepare some solutions, and these are our solutes, like solid, liquid or gas, that can be dissolved in a liquid solvent. Okay, so we have to study about that. When we see the solubility unit, it can be depending upon that amount of the substance in which it is measured. Maybe it is gram per milliliter, gram per liter, or sometime in mole per liter also. Okay, because you know that we used to measure the concentration in terms of the mole also, like whatever the amount of the solute which is dissolved in a given amount of solvent, that how much mole of it is dissolved. So that can also be used to find the solubility of the solute in a given solvent. So the unit can be accordingly. Okay, so that is solubility. Now we are going to see the solubility factors which affect the solubility, means the factors which are going to affect the solubility of a given solute in a given solvent at a specific temperature. So what are the important factors here that we are going to discuss, but we are going to discuss it in a different type of solution. Like first, we are going to discuss about the solid in liquid. It means when solid solute we are dissolving in a liquid solvent, then what are the important factors which can affect its solubility? So the first factor is temperature. Okay, now when we say temperature and when our solute is solid, you know that solid particles are very close to each other, and if you are going to dissolve it in a liquid substance and you are increasing the temperature, so solid particles also gain energy, and when they gain energy the bond between them will break, or the particles used to move away from each other, and when they move away from each other they will diffuse easily or they will be dissolved easily in the given solvent. So basically with increase in temperature, the solubility of the solid substance in a liquid is going to be increased. So in this case, the temperature is going to be directly proportional to the solubility. Okay, because when you increase the temperature, then the particles are going to gain energy. When they gain energy, they will move apart. When they move apart, they dissolve more. Okay, so that is how temperature is going to affect the solubility of solid in liquid. Okay, now we come to the another term, that is pressure. Now what is the role of pressure here? If the particle is like gases or maybe liquid sometime also, then if you are in varying the pressure, you are changing the pressure, then pressure may affect, because pressure usually compress the things. Okay, means bring the particles together. But in case of the solid, already the particles are compressed. So pressure is not going to play any important role for the solubility of solid in liquid. That is, pressure is going to be independent in this case. Okay, that is, pressure has no role to play for the solubility of solid in liquid, as solid particles are already compressed. Okay, and pressure plays an important role in compressing the things. Okay, so in this case the pressure is going to be independent. Okay, that is, it's going to have no effect of pressure for the solubility of solid substance and liquid. Okay, so that is how these two factors are going to affect the solubility of solid and liquid. Now we are going to see one more important solubility, that is the solubility of the gaseous substance in liquid. Student, now we are going to see the solubility of the gases in liquid. It means we are talking about the gaseous solute in the liquid solvent. Okay, so again the two factors are there which are going to affect the solubility of the gases in liquid. That is, one is temperature. Now when we say temperature, you know that gaseous molecules are already far apart, and if you try to give energy by increasing the temperature, suppose if you increase temperature, then what is going to happen? The gaseous molecule is going to gain energy, and when they gain energy they will start moving further away from each other, and then in such case they will be not able to dissolve in that given solvent. Basically they escape out of the solvent. So it means the temperature is going to play again an important role in the solubility of the gases in liquid. When you increase temperature, the solubility of the gaseous molecule in the liquid is going to be decreased, because molecules are going to gain energy and move further apart. Okay, so in this case, that is that when we are talking about solubility of gases in liquid, the temperature is going to be inversely proportional to the solubility. Okay, that is, the temperature, if you increase, the solubility of the gases in liquid is going to be decreased. Then the second factor, that is pressure, like we have already discussed in the previous case, that pressure has no role to play when we are dissolving the solid in liquid, but here the pressure will play an important role. How? Because we are now talking about the solubility of gases in liquid, and gases are already far apart. So if pressure is applied, suppose we increase pressure, then gaseous molecules will come further close, and when they come further close, it means they have a greater chance to get dissolved in a given liquid. So here the pressure is going to play an important role. So basically what we can say, that pressure here is going to be directly proportional to the solubility of gases in liquid. That is, pressure is going to be directly proportional here. Okay, temperature is going to be inversely proportional and pressure is going to be directly proportional here. Okay, so that is a very, very important factor. Okay, like in case of the solid and liquid, temperature was directly proportional, but pressure has no role to play, it is independent. Here it is going to play an important role. If you increase pressure, then solubility of the gases in liquid is going to be definitely increased. Now we are going to see a law based on this factor only, that is a role of pressure on the solubility of the gases. So that law is known as Henry's law. Now what Henry states? Henry states that pressure of a gas, okay, at constant temperature. Now this is important here. Pressure is going to play an important role when the temperature is going to be kept constant. One variable we have to take constant. So here the pressure of a gas when the temperature is kept constant is going to be directly proportional to the solubility, okay, solubility of gas in liquid. So this law is especially for the gases in liquid only, and it states that a solubility of a gas in a liquid is at constant temperature is directly proportional to its partial pressure, okay, that is the pressure of the gas. Now when we see pressure, suppose we denote the pressure by P, okay, any gas, and the pressure is denoted by P, that is P is here the pressure of gas, or we can say the pressure applied on the gas, okay. And when we are saying solubility, solubility means the amount of the solute present in given amount of solvent. So here we are talking about the solubility in terms of its mole fraction. Mole fraction, if you remember, mole fraction means that the number of moles of one component with the ratio to the number of moles of total solution, okay. And here we are going to consider the mole fraction of which component, that is solute. So solute here is gas, so it means the pressure of the gas is directly proportional to the mole fraction of a gas in a given solution, that is it is directly proportional to XB, okay. If you remember, B, I am using the term for solute, so XB means that is the mole fraction of gas, okay. XB means mole fraction of a gas. So the partial pressure of a gas, that is PB, is directly proportional to its mole fraction. When you all know, when we remove the sign of proportionality with equivalence, then we have to keep something constant here, and that constant is going to be KH, okay. It's a symbol and the formula will become KHXP. Now where KH is known as Henry's constant, okay. Now the value of this constant is not fixed because it will vary for different gases, okay. There are different gases, so the value of the constant is also going to vary for different gases. So what we conclude, that the pressure of a gas is directly proportional to its mole fraction in a solution, and pressure of a gas, that is denoted by PB, is equivalent to KH, Henry's constant, into XB, which is a mole fraction. So this is going to be a formula, and it has many application too. That is, Henry's laws has some application too also in our daily life, okay. That is when we are talking about the solubility of a gas in a liquid, okay. So we are going to see some of these applications. Let's see. We're going to see the applications of the Henry law. Now the first application which we are going to see here, that is the dissolve carbon dioxide in your cold drinks, okay. I'm using the word cold drinks here. Usually we all used to drink. Now that is that we are going to dissolve the carbon dioxide in the cold drinks. How we know that? Suppose you buy a cold drink and when you suddenly open it, a fizz sound used to appear, okay. A fizz sound used to come. You see the air bubbles also there. Now what is that? Basically the carbon dioxide is added in that cold drink under high pressure, okay. when you remove that seed or you open the cap, that pressure is released, and when that pressure is released, suddenly the gas came out. Okay, so it means when you apply extra pressure, then under the high pressure the carbon dioxide gas is dissolved in your cold drinks or beverages, cold beverages we are talking about. So that carbon dioxide is dissolved under high pressure. That's why that cap is sealed packed, because the pressure is required to be maintained in order to keep that gas in that beverage. Okay, so it means here you can see this is an application of Henry law, that more the pressure applied, greater the amount of the carbon dioxide will remain dissolved in the cool drinks, and when you release pressure, the gas came out. As is simple. So that's why the air bubbles you can see in there. So that is one of the application. Then we move to the second application. Second application is that you all know that mountaineers. Okay, we are talking about the mountaineers which are going to the high altitude. Okay, mountaineers always carry oxygen cylinder with them. Okay, they used to carry the oxygen cylinder with them. Why? Now we all know, we all used to say like that, suppose we are going to the higher altitude. Okay, any mountaineer or anyone is going to the higher altitude, what is the common problem there? That we used to say that oxygen is less there. Okay, and because of the less oxygen, we used to carry the oxygen cylinders to have the sufficient amount of the oxygen. But actually how it is related, with the problem, I tell you that when we go to the higher altitude, it's not the problem that oxygen is only less there. We used to breathe that oxygen. Now what oxygen will do, it will goes into our blood, and under the normal condition of the pressure, that oxygen used to remain dissolved in our blood, and with the blood it moves to our tissues and everything and do the respiration. You all know about that, and then we are getting energy to do work. Okay, so that is how the oxygen work for us. But when we move to the higher altitude, what is happening here? Not only oxygen is less, basically the air is less over there, and when air is less, basically the pressure of the atmosphere is going to be very, very low. Now when the pressure of the atmosphere is low, under that pressure, if suppose some oxygen is present there, that will also not be able to dissolve in our blood. You understand that? Under normal pressure condition, that oxygen is dissolving. We are breathing in and oxygen is dissolving in our blood, and that causes respiration. But there oxygen might be present, maybe some small amount, but that small amount also we are not able to breathe in, because that will not be dissolved in our blood due to the low pressure area. Okay, that is the pressure over there is very, very low. Now because of that, the mountaineers used to carry the oxygen cylinder with them, under which the gases, that is oxygen gas, is kept under high pressure. Okay, that pressure under which we can breathe that oxygen and dissolve in our blood and carry out our respiration process. So that's why the mountaineers used to carry the oxygen cylinder with them. So that is a very, very important application, and it is related to the respiration process. Otherwise, if the oxygen deficiency will be there, then what it will cause? The person may lose his sense and will suffer from a disease that is due to the deficiency of a oxygen, which is known as anoxia. Okay, it's a disease due to which the person will be lacking the oxygen in their system, that is, will not able to respire properly, will not perform respiration. This disease is known as anoxia. Okay, so in order to avoid this anoxia, oxygen cylinder must be carried by the mountaineers, and that oxygen cylinder will be having the gas dissolve under high pressure, which is an application of Henry law. So that is how it is applicable to the mountaineers carrying the oxygen cylinder. And if they are not going to carry, then we are going to suffer from this red anoxia. Red means danger. Okay, now one most important thing, the third one, which is again related to the oxygen cylinder, that is, we are talking about the scuba diver. Okay, we are talking about scuba diver. Now what is these scuba diver? Scuba diver means deep sea divers, under the sea. Okay, if you have seen that people used to go under the sea by carrying the oxygen cylinder with them. So those scuba divers used to carry the oxygen cylinder under the sea in order to have a sufficient amount of oxygen. Okay, but one important factor here, under the sea the pressure is very high. That's why the oxygen is not only the thing which is carried by the scuba diver, means oxygen there present in the gaseous cylinder of the scuba diver will be diluted form, and usually that oxygen is mixed with an inert gas that may be nitrogen. Okay, initially the nitrogen was used. So those scuba divers used to carry that oxygen diluted with nitrogen, okay, under the sea. Now what the problem they used to face, now if they are going under the sea, okay, the pressure is going to be very high. It's not normal atmospheric pressure. The pressure is very high over there. When the pressure is very high, what is going to happen, that nitrogen gas also get dissolved in our blood. Okay, you understand, because we usually don't respire the nitrogen gas, but under the sea the pressure is very high. So when the pressure is very high, this nitrogen gas also dissolve in our blood. Okay, although it will not cause any harm because it's an inert gas, but the problem is when the scuba diver come to the sea surface, okay, suppose diver is here and here the nitrogen is dissolved, okay, and when it comes to the sea surface, then at sea surface the normal pressure condition is there, so it start releasing the nitrogen gas. Nitrogen gas start releasing from that point, and when nitrogen gas start releasing from that point, what will is cause? It cause the bends, a disease in those scuba divers. Now why these bends occur? Because when nitrogen is suddenly released from the blood vessels, then it create air bubbles. You know, suddenly the space is created because gas came out, okay, from the blood vessels. So that air bubbles cause the disease, a painful contraction in all over the body for those divers, painful contractions, and that disease is known as bends. Okay, so that is a problem, although it's an application, but that become a problem when nitrogen is used along with oxygen in diluted form for the scuba divers. So now instead of nitrogen, it is replaced. Nitrogen is now replaced with a gas helium, which is not released as quickly as nitrogen does when we move to the surface. Okay, that is scuba diver move to the surface. So it prevent them from having bends. Otherwise, the bends can be created. So this is again an application of the Henry laws. Okay, students. So today what we have discussed about solubility. We have discussed about that solubility of different type of a solute in a given solvent, and we have discussed about the factors affecting the solubility of that substance, and we have discussed about Henry law and applications of Henry laws. So these are very important topics, just go through it. So today that's it. Now in the next video we are going to discuss further from the Henry law. So keep watching, subscribe my channel, share it to maximum, and don't forget to press the bell icon. See you in the next video.